Okay, this is part 2 of the recording on the introduction to compound inequalities, and in this recording I'm just going to take you through very quickly the solutions to the practice exercises. Okay, so in the first question we're being asked to graph the compound inequalities on the given number line. Here we have x larger than minus 2, smaller than 5, and so it's between those two values. Neither of those values are included, and so we have an open dot on minus 2, an open dot on 5, and we are joining the two numbers. Okay, for B, x is between 0 and 9, including 9, not including 0. So open dot on 0, solid dot on 9, and we are joining the two, indicating it's all values between those two, but including 9 and not including 0. Okay, in C we have x larger than or equal to minus 2, but smaller than, not including minus 1, and so we have a solid dot on minus 2, we have an open dot on minus 1, and it is all numbers in between. Remember, it's not just the number minus 2, it could be the number minus 1.5, minus 1.6, etc. And so a very small solution set relatively, but nonetheless a large number of fractions in between minus 2 and minus 1. Okay, and now we have the alternate version of the compound inequality. In this case we're being given that x is less than 5 or x greater than 0. Recall that we do not need an overlap in the case of a compound inequality joined by the word or. And so we have open dot on the number 5 going to the left because it's less than, and then we have an open dot on 0 and we are moving to the right. And so technically, even though for instance the number 0 is not included in the right hand side compound inequality, it is included in the left hand side, and so ultimately what results in question 1D is that all, x is an element of all real numbers. It can actually be anything. Okay, and so now we move to question 1E, x less than or equal to 5 and at the same time greater than 0. And so once again we could rewrite this if it's a little bit easier. X is going to be larger than 0 but smaller than or equal to 5. In other words, between 0 and 5, not including 0 but including 5. And once again we'll just join those two. Okay, now we have x less than minus 5 and greater than 1. You need to watch out for this question because it is in fact not a trick question but a tricky question. We have an open dot on minus 5 going to the left. We have an open dot on 1 going to the right. And in this case, however, since it's AND, we need the set of numbers which simultaneously satisfy both of the inequalities. In this case, there is no number which is both bigger than 1 and at the same time smaller than minus 5. And so what we actually have in this instance is a no solution or empty set. There are no numbers that satisfy both of those. Okay, part G, it's the exact same question as part F with the exception of the word or replacing the word and. This will have an acceptable solution. We will start at 1 and include all the numbers to the right. We will start at minus 5 and include all the numbers to the left. And so in this case, the solution set is acceptable. Okay, if we move on now to the second example, we are asked to circle all values that are part of the solution set. So we've been given our graph, and really what we're trying to do is identify whether or not the numbers listed are included in the solution set represented on the number line. Minus 3 clearly falls between the two and is not included. The number 5 is included, as is 7, as is 11. Even though it's not represented on the number line, The arrow at the end indicates that it's all numbers larger than 4, which includes 11. 0 is clearly between, and so that is not included, whereas minus 8 falls to the left of minus 6 and is therefore included. Okay, moving on to our second page of exercises. This time we are given the graph and are asked to write the compound or combined inequality. Here we have minus 6 as our starting value. X is larger than minus 6. It is simultaneously smaller than or equal to 3. The other acceptable version of the answer would have been x greater than minus 6 and x less than or equal to 3, the important word being and. In the second example, in question 3b, exercise, your correct solution set should have been x less than minus 6 or x greater than or equal to 4. Okay, and then in the final question of the exercises, we are asked to translate each of the following into a compound inequality, and so effectively we're going to write a compound inequality using or translating the given words into a math expression. So we want all numbers between minus 8 and 3. X is going to fall between them. It does not include minus 8 and 3. And so we have minus 8 less than x, which is less than 3. In 4b, we have all numbers larger than 2, and the keyword again, or smaller than minus 3. And so here we have x smaller than minus 3, or x larger than 2. Okay, in 4c, all numbers at least, this means greater than or equal to, at least as big as 4, and so once again we are interested in the overlap, at most 12. So once again it does include 12, and so at least as big as 4, which means 4 or more, but not continuing to numbers like 50, because it is at most, so less than or equal to 12. Okay, and our last question, all numbers larger than, so bigger but not including, larger than 7 and smaller than minus 3. And so once again, what we have in this case is an empty set. There are no numbers which are bigger than 7 but simultaneously smaller than minus 3.